Hi, and now we start this teaching presentation. Okay, let's first look at question 1. In question 1, we have the question about the estimator. And first, we need to estimate the mu in the normal distribution, which represents the mean value. And in here, so we directly estimate mu by x bar. We simply sum up all the xi and divide it by n. So with this x bar, we can also get another estimation, which is about the theta hat. And in here, theta hat is equal to e to the power of x bar minus 1. And since x is follow the normal distribution with mu unknown and the sigma square equal 4, and then we can get the x bar is follow the normal distribution with the mu and sigma equal to 4 over n. And by the central limit theorem and the confidence of 96% we get, so we can directly count up the interval shown on the slide. And the part B of this question is similar with part A, and this time we know that mu is equal to 10, and we need to count the sigma square. And here, the sigma square means the variance of the data, so we can simply count the variance shows like the method shows on the slide. And once we get the sigma hat, we can use the similar method to count up the interval we need in this question shown on the slide. And we move to the question 2. And in the part A, we need to write down the likelihood function of the theta, and his theta we get is defined by the p y1 equal 1. And in the question we know if the yi is equal to 1, it means that the xi is larger than 0, and x is follow the normal distribution. So we can directly count the probability of xi larger than 0 as the integral shown on the slide, and it is equal to 1 minus the capital theta minus mu, and is equal to the capital theta mu. And then the little theta equal to the capital theta mu, and then we consider its likelihood function L theta is equal to theta to the power 4 times the 1 minus to theta to the power 6, because in the question we have known that there are 4 positive data and 6 non-positive data. So we take the logarithm and to get the log likelihood function shown in the slide, and it is equal to 4 times log theta plus 6 times log 1 minus theta, and we take the derivative and take the second derivative and find it the second derivative is smaller than 0. So what can we get in this information is that once the first derivative of the log likelihood function is equal to 0, we will get the maximum value of the log likelihood function and also the likelihood function. So in this time, the theta is equal to 2 over 5. So we take the value of theta back to the to the likelihood function L theta, and we'll get that the theta hat is equal to 0.4. And the part B is easy. Once we get the information of part 8, we directly take the 0.4 to the inverse capital theta, and we get it is approximately minus 0.253. And then we move to the question 3, and the A part of question 3 is easy. You just try to find the mean value and the variance of x. And since the probability of x equal to 1 and x equal to 2 are given in the question, so we directly use the 1 times the p x equal to 1 and 2 times p x equal to 2 to get the means. And the variance, we can use the simple formula to count it up once we get the ex. So it's very simple, and the steps are shown on the slide. And in the part B, we need to check the estimator theta n hat is equal to the equation given in the question. So it is also easy because by the weak law of large number, we know that the x n hat it will close to the mu, and the ex we have already count in the question in the part A. So we can directly check the theta n hat, and we will find that is equal to theta. So it is proven. So the part B is finished, and we come to part C. So in part C, we have known there are some data of x, and we need to find an interval of it, of the construct approximate 95 CI for theta in this question. So the first step, we need to count out the averaging, the means of the all data. So in here, we find that it's 1.4, and we also find that the theta n hat is approximately 0.571, and we get a gx, which is equal to minus ln x, and we take the first derivative of it, and we take the value of theta n hat to the function g, and we get it is approximately minus 0.58. And by using the delta methods, we find the variation of 0 n hat, and we also find the variation of the g theta n hat, and we get approximately the theta n hat is equal to 0.571, and the variation of 0 n hat is approximately 0.025, and the variation of g theta n hat is approximately 0.245. And by some formula, and we get that the z of 0.025 is 1.96, and then we can use this data to find out the interval shown on the slide. And the D part of this question is just a comment, and we think this comment is reasonable but a little bit wide. So this is my presentation of this assignment.